Example 1. Chapter 8. Consider a Carnot-cycle. A Carnot-cycle have a isentropic isothermal against isentropic and also again isothermal. So let me write as heat pump with refrigerant R134A R134A as refrigerant working fluid, and the problem described heat is absorbed into R134A at 0 degree temperature, during which process it changed from a two-phase stage to a saturated vapor. As a first stage, we have a T 0 to T equals to 60 degree. From the change from a two-phase state to saturated vapor. Liquid, two-phase, and saturated liquid, saturated vapor. Three stage, and for the heat is rejected from the R34A at 60 degree isothermal. This process ends up to a saturated liquid. T equals to 60 degree ends to saturated liquid. Find the pressure after compression. Pressure after compression. Before the heat rejection process, and determine the COP of the cycle. At first, we should use PV and TS diagrams. For TS diagram, we have for example, a point at T equals to 0, the start point. The next is a saturated vapor. And goes to the saturated liquid. 1, 2, 3, and for example 4, which is for TS. Heat rejection is Q and also Q. We have also a PV diagram. It is important to PV. We have also the same. Excuse me. One, one, 2, 3, 1, 2, 3, 4. We have a midpoint for a change 2.2 to 3. At first it goes to from superheated to saturated vapor and saturated vapor to the liquid, saturated liquid, because it is impossible to directly go to the point 3. It should be first converted to saturated vapor and from saturated vapor at constant pressure P and P. Find the pressure after compression. We have, during the PV diagram, we have a expansion. Find the pressure before compression. Before compression, we have compression process. This is an expansion process. The pressure from higher goes to the lower pressure. The compression process occurs in this part. The pressure before compression is at point 2. So we should first determine point 1. Point 1 is for R state for the heat is absorbed into the R34A at 0 degrees centigrade, during which process in change from a two-phase state to saturated vapor. The first point is point 4, two-phase. Two-phase and T equals to 0 degrees centigrade. from table. I recommended that check the table. The work with tables was exercised in the previous chapter and available in the problem solution for the related to chapters 4 to 7, I think. So for this table we should first extract the entropy S4, which is also equals to S3 during the diagonal TS. We can write the from the point, because point 3 is saturated liquid, we can equals to SF at 60 degree, point 3. Kelvin. At point 3, saturated liquid. So again we can extract the point 1 saturated vapor, 2 and 2 primary. For table, saturated vapor B51 S1 equals to S2 prime equals to S2 equals to Sg saturated vapor at 0 degrees centigrade, which is now we have the information about. Let me provide the picture here. TS point 1 at 0, we have information about this point. Point 1 0.2, 0.3, 0.4, and also a midpoint here, 2 prime, for example. We have S1 equals to S2 equals to S2 prime, superheated. We have S4, S3, two is superheated. The compression process starts at point 2, which is superheated. Table B2 1, excuse me, B5 2 are superheated, and we have T equals to 60 degrees centigrade and S equals to 1 kilojoule on kilogram Kelvin. From this table we can find that for S and T the pressure is between P1 and P kilopascal with S equals to from the table we know, and also from the table. P is on. We make an interpolation. We have P minus and equals to so P can be calculated and is we know that delta Q TdS. So Q can be calculated T delta S or COP. For COP we have QH on W in QH on QH minus QL COP TH minus TL. TH minus TL is 60 degree. Our temperature difference. COP is